Anil Kumar will discuss intersection of lines in this particular video. The question here is, determine the number of points of intersection for the following set of lines. So we are given vector equation of a line and a symmetric equation of a line. These are two different lines. We need to find the number of points of intersection, right? So number of points of intersection could be 1, could be 0, or could be infinite, right? So it is 1 if we have any two lines which are not skew lines and not parallel, then 1. If the lines are skew and parallel, then 0, and if coincident, then infinite, right? So let me write down these terms. So what we have here is we could have parallel lines and skew lines. Now, skew lines are the lines which are not parallel, but they are in parallel planes. So here we have 0 point of intersection, right? So no point of intersection. And when do we have infinite point of intersection? So we have infinite number of points of intersection only if we have coincident lines, right? So in that case, we have infinite points of intersection. Else we have just 1, right? So these are the cases, right? These are 3 different cases which will give you the combination of 0 and infinite, and all others will give us 1 point of intersection. So to begin with, let us check the direction number. So let's find the direction vector first, right? So let's find direction vector of both the lines, right? As far as the first line is concerned, you can read it. It is -1, -1, 4. So we say D1 is equal to -1, -1, 4, right? So that's the direction vector of the first line. And as far as the second line is concerned, we can read this as equal to 5, 5, and -20. 5, 5, and -20. Now from here, we can say that D2, if I take 5 common, let me write here, if I take 5 common, what do I get? I get rather -5 common, then I get -1, -1, and 4, right? So that means it is a scalar multiple, right? And that really means that they have same direction, right? So they have same direction. Now if they have same direction, then we could have two things. We could have either parallel lines, or we could also have coincident line. That is important to understand. So if you stop here and just say that the lines are parallel and there are no points of intersection, your answer can be wrong, right? So I hope you understand this concept. So this was the concept part. Now how do we find whether these lines are parallel or they are coincident? The only way to find this is, we know that the point on this line R1, we'll call this as position vector on R1 as 1, 2, -3, right? So this is a position vector on R1. The first line, we'll call them as line 1, okay? If this position vector is also there on the second line, in that case, we can say that the lines are coincident. Is that okay? So that is how we can say that the lines are coincident. So what we will do here is we'll just substitute this value here and see whether it works or not. If it works, that means this point lies on the second line also, right? So I'll substitute x as 1, y as 2, and z as -3 in my second line. So let me call this as line 2, right? This we are saying is line 1. Okay. So when I substitute the coordinates or the position vector 1, 2, minus 3 in line 2, what do I get? I'll not write equal to, but I'll just check what do I get. So we get x minus 3. I'm substituting x equals to 1, right? So instead of x minus 3, we have x minus 3 over 5. I'll substitute 1 here. So I get 1 minus 3 over 5, which is equals to minus 2 over 5. Is it okay? Now in this second equation, we have, let's say, y minus 4 over 5, right? So I'll substitute y as 2 here. So we get 2 minus 4 over 5. What do I get? I get minus 2 over 5. And the third part of this symmetric equation is z minus 11 by minus 20, right? So if I substitute minus 3 here, minus 3 minus 11 over, 20, minus 20, what do I get? So this is minus 14 over, so this is minus 3, right? So minus 3 and minus 4, minus 14 over minus 20. And if I simplify this, so we're dividing by 2, we get 7 over 10, right? So definitely this is not the same as the other two, right? So this is 7 over 10, which is not the same as the other two, right? And therefore we say that this point really does not lie on this second line, and therefore we conclude that the lines are parallel. Since the lines are parallel, it implies that the number of points on which it intersects is indeed 0, right? So there is no point of intersection. Correct? So that is how you can figure out whether the lines intersect or not. If they intersect, they will intersect at one point, and if the lines would have been coincident, then they will intersect at all the points, and we can have infinite number of points of intersection. I hope that helps. Thank you and all the best.